Okay, it's 11, so we'll get going. Um, Today we're going to do a webinar on sediment basin or skimmer basin design. We're going to focus today on Georgia and Texas. Each month we do these, we try to put a little bit of a focus on different states, but for the most part, the majority of information we'll go over applies in most areas. Real quickly about me, I'm Jamie McCutchen. I'm a 92 grad of Clemson University in civil engineering. Founded CCAD Engineering, which was a small engineering company in 1999. I sold it in 2018. I invented the Marlee float skimmer back in 2013, and I am a licensed professional engineer in South Carolina, North Carolina, and Georgia. I say all that just to let you know that this is intended to be a technical presentation. Hopefully, we're going to give you some information. You'll find it useful and learn something today. Make your design and permitting go a little smoother. And at this point, I am going to cut off my video just because it helps with the recording later. So, all right. So today's agenda, we're going to do an introduction to skimmers or floating outlets, kind of talk about why we use skimmers. We're going to talk about the basics of skimmer basin design and the importance of some critical design criteria. Then we're going to take a pivot. We're going to talk about permanent use of skimmers for post-construction, which is maybe a new concept to many of you. And we're going to wrap up with introducing our newest product, the Rymar water quality filter, and kind of talk about first flush design versus filtration-based design. So as we get going here, I'm going to launch a couple of polls during this. So just let me know how familiar you are with skimmers. This kind of helps me gauge our audience today. Usually we have 40 to 60 people on these, so it'll give me a good feel. So, all right, we've got a little over half the people have filled in, and it looks like majority are, or at least somewhat familiar or very familiar. So looks like I've got a fairly educated group here today that's used to using skimmers. So. All right, so for those that are not necessarily, we used to have ponds without skimmers, and we would withdraw from the bottom of the pond where the sediment accumulations and concentrations are highest. The whole idea of a sediment basin is to give time for the water to settle so the sediment goes to the bottom. So it necessarily didn't make the best idea to then discharge from the bottom of the pond where that sediment concentration is highest. Skimmers have been around now for I think about 25, 26 years. They're actually a fairly simple concept. They float and release water from on the surface or near the surface, drain the basin from the top down, where that water is cleaner, releasing the water from the cleanest part of the water column. And they do a very effective job of increasing the trapping efficiency of the sediment basin. The Marlee float's a little different than others. It has a debris guard around it, and its inlet is actually below the water surface. So water comes in a grate kind of in this area, goes into the body, and they have an orifice or control for the flow here, and then goes out. So one advantage of that is that the floating stuff that's right on the top has a very difficult time getting to the orifice to clog it up. There are a number of skimmers on the market. The Faircloth skimmer has been around the longest. It's kind of started this. Mr. Faircloth's out of North Carolina and did a good job of introducing it there. And from North Carolina, it went on to EPA and then started getting around to other states. The erosion supplier ESC is kind of similar to Faircloth, got the IAS, and then you have the Marlee float, which obviously looks a little different than the rest of them. So I don't know how many of you actually seen a skimmer in action. I don't know why it paused there. Hold on, let's get it to play. There we go. But this is a site in Anderson, South Carolina. It's about an 8-acre disturbed site at this time. See that sediment basin was pretty muddy. This is the outfall from the skimmer, and actually relatively clean water compared to what was in the basin. So probably one of the best firsthand examples I can show you of how effective skimmers are. It was very important for this site because this site was about 100 yards from Lake Hartwell. And it was very important to the client that we did not turn the lake red or brown during construction. So just kind of, recap. ponds with skimmers versus without. The water withdrawal without a skimmer is coming from the bottom, with the skimmers coming from the surface where that's cleaner water. It's not clean water by any means, but it's cleaner. Sediment retention, when you have a discharge from the bottom, is you have more sediment resuspended, more chance of that sediment getting, discharged. Whereas with a skimmer, it settles to the bottom better. Output quality, high turbidity without the skimmer, from the bottom. I wouldn't say clear water. Probably need to change that. Cleaner water with the skimmer. And maintenance, much more frequent clogging when your outlets at the bottom versus the skimmers tend to be less frequent maintenance. And when they do, it's pretty easy to get to. And often you can reduce the size of the basin with the skimmer. So there's three fundamentals of sediment basin design. Basin fundamental number one is just basin volume. That's simply the volume per acre that is required to go to the pond. So regulations differ as to the total area and whether they require a disturbed area or total area. What we generally see is a requirement of 1,800 to 3,600 cubic feet per acre that's flowing to the basin. Some areas also require basins to have a permanent pool or sediment storage volume that is not drained by the skimmer. One thing you'll hear me harp on here this morning to start off is make sure you're using the required volume, not the actual volume of the pond to size the skimmer. This is very important, especially if the pond's going to be converted to a permanent detention pond and may have a much larger volume than what's required during construction. Fundamental number two is simply dewatering time. So most states have a range of time that they've specified. The general standard is 2 to 5 days. It's probably the most common. 1 to 3 is probably the second most common, but whatever that state requirement is. And then number three is just flow rate. So it's simply the volume divided by dewatering time to give you that flow rate. We do recommend that you establish that range of flow rate when you're doing your designs and not a precise flow rate or time. That allows contractors a little more flexibility if they do want to try to swap out a skimmer for an equal, if it's a range. So one of the best firsthand examples I have of the importance of required storage versus provided, this was taken off of a plan set, and I believe it was out of Georgia. The engineer had specified a 72-hour drain time, an 8-inch skimmer size. He had specified a Marlee, which we appreciate. The required volume, and he has a sediment storage, or the engineer has a sediment storage required, but that's really dewatering volume, was 1,754 cubic yards. That would actually require a 3-inch skimmer with a 2.5-inch orifice, which would be at about $1,100 item. The provided volume, so the actual volume of the pond, was 7,500 cubic yards, or just under that. That would require an 8-inch skimmer, actually with a 6.5-inch orifice, and much more expensive item, about just under $6,000 item. But the key here is that if you use the 8-inch skimmer, it would drain that required volume in less than 9 hours. So if you've got a standard of 24 or 48-hour minimum drain time and you're discharging in only 9 hours, then you're not meeting the standard, your site's not compliant, and most likely you're letting out a lot more sediment from that basin than would be preferred. So one more poll here. Talk about location. So I know we have got about 55 people or so that have joined. So if you would, let me know where you're joining us from today. If your state is not on the list, if you just put in other and maybe add in the chat just to tell us where you've joined us. So looks like we've got a group from all around the country today. So give you one more minute to put that in. So in that, we'll share the results. So looks like Ohio and other are the two majorities here. We've got a few from Indiana and Pennsylvania, Texas, Virginia, and Georgia as well. So appreciate everybody that's joined. So in the chat, we have someone from Canada and from Montana. We haven't had a lot of either of those. So appreciate you joining us today. So we'll keep going here. Like I said, today we're going to be kind of talking about the Georgia standards and Texas standards. Again, each month we try to mix this up and talk about different states. So one thing with Georgia is when they redid their green book back in 2016, they tried to go to more performance-based standards versus proprietary standards. And in doing that, they hired a company to test skimmers, and they found out that each product um, had a unique design and that the flow rate was very dependent on each product. And so they put in here that discharge rate is dependent, and you should base your design on product specific testing criteria. When you do your basin design, again, you've got 67 cubic yards per acre, which is that 1,800 cubic yards per acre is your required storage volume. They want you to determine your minimum elevation for your storage volume in your basin. Other thing is they have this chart that they want on the plans. So you've got your trap size, top and bottom, length and width, and the depth. The time to drain, Georgia actually does not specify a specific range of time. We recommend as the engineer that you specify either somewhere between a 48 to 72 hour time. So what we see most common is a 1 to 3 day time frame. Got your skimmer dimensions and manufacturer's name. So you want to fill that little chart out for all your plans in Georgia. But main thing I wanted to add there is that specifying that range of time. But again, they leave it up to the engineer as far as what that range needs to be. Texas standards. Texas has just recently started enforcing standards for skimmers, although they've been in their CGP since 2013. Texas is one of the states a little bit different. They want you to calculate the volume based on a 2-year, 24-hour storm, but they want it to be at least 3,600 cubic feet per acre drained. So it's not a straight line, 3,600 cubic feet. That's a minimum. They typically want you to calculate it based on that 2-year storm event. And they do want you to utilize outlet structures that withdraw water from the surface. Again, that's been in their CGP since 2013, but we just now starting to see that enforced in most parts of Texas. The minimum design dewatering time is 36 hours, and the max is 72. So they've got a 1.5 to 3 day time frame. We'll design the outlet to handle a 25-year, 24-hour storm. The basin's primary outlet would be the skimmer plus the riser structure or emergency spillway if it doesn't have a riser. And then you want to withdraw from the surface unless infeasible. And then the discharge rates, again, are dependent on the skimmers, and so use the manufacturer's flow charts to do that. So they also recognize that skimmers have different flow rates. And then they have this little design form, has the same information. Again, that minimum required volume or the 2-year, 24-hour storm to do that. So this is a little quick chart here to kind of go over some differences in different states. We've got Georgia, Tennessee, Indiana, Texas, Louisiana on here. Just pick those for today. You'll see basin volume. They're in the 1,800 cubic feet to 3,600 cubic feet range, except for Indiana. They require 5,600 cubic feet. Also, Tennessee and Indiana require that wet storage or sediment storage. Tennessee, 1,800 cubic feet per acre. Indiana, 1,000 cubic feet per acre. Surface area, some states have a formula. Others have kind of preferred depth or a minimum length to width ratio. Principal spillway, typically anywhere from the 2-year to 10-year storm. Emergency spillway, 10-year to 25-year storm is pretty common. Where skimmers are required, that does vary. A lot of areas are 10 acres or more, or maybe 5 acres or more. Some are any sediment basin. And way we see this enforced in the real world is if you've got a riser structure, they typically want a skimmer. If it's a sediment trap with maybe a rock outlet, then you probably, you're not going to do a skimmer. The rock outlet is going to be that. And then dewatering time, Georgia, again, 24-hour minimum is kind of what we see enforced there. We recommend that 1 to 3 day range. Tennessee has a 1 to 3 day. Indiana is 2 to 3 days. Texas is 1.5 to 3, and then Louisiana says within 2 days. So that's probably the biggest thing when you're looking at the differences in state is to key in on the basin volume for that state and the dewatering time. So one thing that people don't recognize or maybe new for you for skimmers is skimmers actually do have a flow rate curve. So this chart was taken from some testing that TRI Environmental did for the state of Georgia when they were updating their green book. And you can see their test tank is 4 feet deep, so they go 1 to 4 feet. They tested 3 different types of 3-inch skimmers here. You'll see two of them had very similar flow rates. At 1 foot of depth, they're around 37 GPM, but type 3 here was nearly double that at 70 GPM. As they went from 1 foot to 4 feet of depth, all three had about a 25% increase in flow rate. Again, two of them were close to each other, around 50 GPM, one nearly double at 90 GPM. So the point here is if you just say 3-inch skimmer and you don't give any more information, or whatever size skimmer and don't give more information, you could get a product that flows significantly different from what you intended. So it's important to specify that drainage volume and time to drain and come up with that flow rate range when you're doing your plans. So I kind of boil it back down here. We call it the skimmer design formula. So step one, calculate that basin volume. So whatever your cubic feet per acre requirement is, let's say if it's a 5-acre site in a state that required 1,800 cubic feet, that'd be a 9,000 cubic feet volume required. Then determine your dewatering time. Again, that's going to be state specific. So whether it's 2 to 5 days, 1 to 3, just check your local regulations. Step three, calculate that required flow rate and what that range is. So, if we had 9,000 cubic feet and had a 2 to 5 day range, pretty good range of flow rate, 1,900 cubic feet per day to 4,500 cubic feet per day. So, you can pick any skimmer that's going to drain that volume within that time frame. And then you want to select that skimmer size. You can match calculated flow to the Marlee flow rates charts, or use our design aids, or whatever skimmer you prefer to use. Just make sure you're falling within that range of time. So for the Marlee float, we have a couple of tools that we're going to show you. So this is our skimmer design tool. It's an Excel sheet. It does factor in the depth and the flow rate at each depth when doing this. So the top here, you're going to have your information. So your project name, engineering name, engineer, where it may be. You got your sediment basin description. So, you may have multiple basins on the project, basin 1, 2, 3, ABC, whatever your preference is. We have this check here for your required dewatering volume. So you want to put in your area to the basin. You want to put in your cubic feet per acre, and it's going to come up with what your required volume should be. Okay. Now, when you put in your inputs for the skimmer and for the basin, you've got your maximum and min time to drain. You got your pond depth, your top length and width, and bottom length and width. Now, your pond depth only needs to be the depth. Oops, there we go. Only needs to be the depth that is needed to reach your required volume. So if your pond is 5 feet deep, and you get your volume at 3 feet, put in 3, not 5. Top length and width and bottom length and width, we're trying to hit typically a 2 to 3 day range of time. So just get this close. We recommend getting the calculated pond volume within about 5% of the required pond volume. So in this case, I'm a little bit higher than what my required is, but it's pretty close to that. When you do that, our tool is going to calculate the drain time for each skimmer with each orifice configuration. All these flow rates are based on third-party testing. Down at the bottom of the page, we've got a skimmer report page tab. You click on it. It'll take you to a nice, neat 8.5 by 11 with all the information on it. These are easy to put in your SWIP or put on your plan sheet. The top of the page is going to have this check here, so the reviewer can very quickly see your calculated volume and your required volume are very close to each other. It's going to tell you the minimum flow rate for your maximum time and maximum flow rate for your minimum time. And then because it is our tool, it's going to tell you each skimmer orifice configuration that does drain the basin within your established range of time. And then you as engineer, pick which one you prefer. In this case, I'd probably go with our 2-inch with a 2-inch orifice. Going to drain in 69 hours, so just under 3 days. That's going to be your least expensive skimmer that's going to fit within that spec and drain it in a good time frame. So, but again, it's up to you as engineer, pick whichever one within that range of time. If you prefer the basin to drain as quickly as possible, you could pick our 4-inch with a 2-inch orifice, would drain it in only 48 hours. That just barely meet that minimum 2-day time frame. So we also provide some skimmer basin details. We have 4 different details. We have this one that has a riser structure and is a dry basin. We have a similar one with a riser structure with a wet basin. And then we also have ones that are a temporary pool or temporary basin that just got a pipe going through the basin as well. Over here, you're going to see the standard criteria for each basin on your site. So you may have a min and max length to width ratios. Here's your minimum volume required. You may have a surface area requirement. Here's where you set your min and max dewatering time. So that's now set for your project. And then down here, we have a data block so you can put in information for different skimmers or different basins. So your drainage area, disturbed area, the Q2 or Q10, whatever it may be in your area. Basin volume, again, you're required and provided. Surface area, make sure that your provided meets what's required. If you have that requirement, outlet information, merchant spillway information. Over here, you get to the skimmer size, skimmer orifice diameter, skimmer manufacturer. Is an equal allowed, yes or no? Most of the time, that's yes. There may be some times when there's a no. And then here's where you set your min and max flow rate for that specific basin. So once you set that and you specify your skimmer, if the contractor comes to you and says, hey, I got the skimmer from this other job, I'd like to use it on this one, can I? Well, as long as that skimmer has a flow rate within that range, then that would be acceptable. You've already had that reviewed and approved during your review process, so should be a simple shop drawing to make that switch. This is our standard detail. And so just a couple of things about it. Each one of our skimmers comes with what we call an orifice plate, which has standard orifice sizes. So that fits in here, kind of goes right in this area. The detail is going to give you the flow rate at 0.1, 0.3, and every half a foot up to 4 feet for each orifice configuration. The most common question we get asked is what length this pipe needs to be. We recommend 1.4 times the height of the structure for that. This is for a dry basin. We do call out for a small depression here. The reason for that is skimmers kind of sit a couple of inches above grade, or if you go in and put a stone pad in at grade, it's going to raise it up. If you're trying to get that basin to dry out entirely, you want a little depression to do that. We also call out for some stone here. The reason we do that is because it's kind of become accepted. And even though I can say I've never seen one of our skimmers stuck in the mud, because the only thing that touches it is the bottom of a round pipe, it's easier just to put that on the detail than it is convince people that it's not needed. So, in order to use it, just go to rymarwaterworks.com, go to the Marlee flow at the top, come down here to sizing calculator. And when you do, it'll pull up this web page. First thing you want to do is if you've got a name for your basin, just enter your basin name. So I'm just putting basin A. The cool thing we have now is this state drop-down box. So we have multiple states in here. And when you select the state, it will fill in part of the information for you. So since we're talking about Georgia and Texas today, I'm picking Texas. So I'll pick Texas there. It fills in the required cubic feet per acre based on what Texas requirements are. Now, again, Texas requirements are that 2-year or 24-hour storm. It fills in the minimum time to drain and the maximum time to drain for you based on what the state standards are. Again, in Texas, 1.5 to 3 days. So if you know your acreage, you can just plug that in here and it will calculate the required pond volume for you. If you prefer, you can just put in, manually enter that pond volume. You can do it either way. And then you can also, if you want to, you can manually change your min and max time to drain. So if there's some reason you wanted to go to 2 to 3 days instead, you could. Now, once you have that, it will tell you each one of our skimmers that drain within that required time frame. And then you can pick which one you prefer. So in this case, I'd probably go with a 4-inch skimmer with a 3.5-inch orifice to drain in just over 2 days. And so you click on PDF and it will then create this PDF for you. You can download it. It's got a chart up here on the top that gives you all the information you need. And really simple way to create that detail for you. Again, the thing that's new is the state drop-down box. If you select different states, it will fill in that required cubic feet per acre and that drawdown dewatering time for you. Really helpful. Probably the most common thing we see on plans we get is especially engineers that work in multiple states. And I've seen it a lot lately for sites in Indiana. They've seen a lot of sites in Indiana that specify a volume of either 1,800 or 3,600 cubic feet. And Indiana's that outlier at 5,600 cubic feet. So a lot of times we get plans in that, 30% stage for pricing. And and we're hoping this is a nice, useful tool that helps you kind of easily, quickly find out what those different state requirements are. Sorry, the volume didn't work there at first. I didn't realize it was playing on my end. Didn't realize it wouldn't play on yours. So yeah, that's good. There we go. All right. So any questions on skimmers for during construction before we jump into post construction?
Yeah, Jamie, question is that you have any sites for Augusta, Georgia, that can be used as a model or sample to show to the contractor and the owner and the county official?
Um, we have a bunch of skimmers being used in Georgia. If you will reach out to me, just shoot me an email. I'll see if we can find out specific ones because we sell through distributors. We don't necessarily talk to the contractors very often, but if you let me know what part of Georgia you're in and
I'm in
where through
Augusta,
it, I'm sure I
Georgia.
can find some.
Augusta,
Say it
Georgia.
again. Okay.
Augusta, Georgia.
All right. I'll reach out to some of our distributors and see if we can find some examples out there. So
Thank you. I
got
may
another
have to
question
leave.
about it.
I may have to leave the seminar earlier because I have an appointment with the county officials today around noon time. So I may leave
Okay.
about 15, 20 minutes early.
No problem. No problem. So
Thank you.
got a question about the other states that require dry wet storage component outside of Virginia. So Indiana does, Ohio does, Tennessee does. Trying to think off the top of my head. Those are the three that are coming to mind. Uh, but we our detail, we do have another detail that uh, does it as a wet basin. So I'll get to that here at the end about where to download those. But we do have details that have it for both the dry basin and wet basin. So, all right. So we're going to now jump into permanent skimmers. So first thing I'm going to do is launch one more poll and just want to know, have you ever considered using a skimmer permanently? Oh man, I'm excited. I've got more yeses than I've seen anywhere. So this is great. And we got a lot of considered. So got a little over half of you have responded. So I'm gonna end that and share the results. So majorities no. Well, actually just a small majority, 20 no's, but 20% have said considered and about 20% have said yes. So that's awesome. We love to hear that. We've been pushing this for a while and excited to know that it's starting to catch on. So for those that have said no or considered, we'll kind of run through why you might want to consider that. So we're going to focus on dry detention basins. Dry detention basins are probably the most common BMP. What we're going to talk about will work on wet detention basins as well. But we'll kind of talk about it from a dry basin standard. So, um, you know, again, just like old sediment basins, it's common that the discharge for your dry basin is located at the bottom of the pond where that sediment concentration is highest, right? And the whole intent here is try to get things to settle in the pond so they don't get discharged. So, discharging from where that sediment concentration is highest may not be the best idea. So what typically happens with the dry detention basin is once your construction is complete, the skimmer is removed, you put some sort of low flow orifice installed at the bottom of the riser to release that first flush. That's the most common terminology for it, but it's that first inch, 1.2, 1.5 inches, depending on where you are, that is draining to the pond, and you're trying to design that low flow orifice to release that volume over 24 to maybe 48 hours. And you're going to do something to try to keep it from clogging, right? Because that's often, depending on the size of your site, it can be a pretty small hole. It can be, 1 to 3 inch size hole in many cases, which is hard to keep from clogging. Well, if you were to look at a storm event and water coming into the basin, if the inlet's here, you're going to see a heavy sediment load coming in. As you travel from the inlet to the outlet, sediment's going to settle, Stokes' law, and your heavy sediment concentration is going to be at the bottom. Your cleaner water is going to be up here at the top near the outlet end of the pond. So if we could release that water instead of this water, we're going to do a better job of, you know, enhancing our water quality and releasing cleaner water from the permanent detention ponds. Like we talked about, basins rely upon the natural settling. Skimmers release that cleaner water from the surface. They have become the standard in most states during construction and proven to be very cost effective. And so it makes sense to use the same methods for post-construction water quality, as it does for construction, if you can make that work. So I'm going to do a little quick case study here. Sorry, I got somebody at my door, so dogs are barking. They'll stop. So this is a pond. This was a former Simpsonville Chevrolet. So you can see it was covered in trees, heavily wooded. Not surprisingly, they got a notice of violation in 2013 for it being severely overgrown and not maintained. So we went in and helped them clean out the pond, cut all the timber out. You see, we cut 6 and 8 inch trees out of this thing. And we could see the orifices here, but it was holding 2 or 3 feet of water in the basin. And so we finally figured out that there was a 2 inch orifice 6 feet below what is now this bottom of the pond. So you can see how much it's filled in here, grown in. So we worked with the county. We redesigned the basin. You see the old orifices here to here. And instead of the 2 inch orifice at the bottom, we got them to agree to put in a 5 inch skimmer as a retrofit. The client, this was a Greenville County project, and to be honest, they denied us the first couple of times we requested this, but we found out that they had a pilot program for innovative stormwater practices, and so we applied for that, got approved, and as part of that, we had to monitor this site monthly for the first year and quarterly for the next 2 years. So, once installed, it looks like this. That's our old skimmer model, but wish the contractor put the bore in right at the bottom, but in any case, it's pretty close to the bottom. So again, we monitor this basin for the first 12 months. These are pictures from it. So the skimmer did a great job of releasing that, cleaner water and doing a good job of draining the basin without getting clogged. You'll see some other pictures here. This basin gets a lot of trash in it. Well, about a year later, the owner had contractors go out and cut the basin. They let all the stuff fall to the bottom and had a big 5 inch rain event in a few hours, washed all the debris down to the bottom. But you see our little skimmer sitting there, was able to drain the basin, without clogging up. Hard to tell in this picture, but these are 6-foot riser sections. So imagine if that had been a 2 inch orifice there and water had been stuck up here about 8 feet deep, getting to that 2 inch orifice would have been challenging to say the least, probably a little dangerous. So even if the skimmer had clogged, it's going to float. You can get to it, pull the rope over the side, shake it out, get it done. So just from a enhanced maintenance standpoint, skimmers can be a very effective option. There's certainly some benefit for enhanced water quality with that, but we haven't done testing yet on the water quality for just the skimmer. So if you're going to use the skimmer post-construction, you got to know how to model it. HydroFlow, HydroGraphs is probably the most common hydrology modeling program now because it's built into Civil 3D. So we can kind of touch just briefly on how you would model a skimmer. So first thing you're going to do when you build your basin, build in stages to be able to enter the flow data that we provide off the detail. So again, we provide 0.1, 0.3, 0.5, then every half a foot up to 4 feet flow rates based on the testing. So then when you build your outlet structure, you got your A, which is your barrel, your pipe going out. So in this case, we had an 18-inch pipe going out. This case was a area that required quantity control during construction. So we had a 6-inch orifice about just under, was 1.75 feet above the bottom of the pond. Had a 3.6-foot tall riser and a rectangular weir at the top of the riser. And then here, kind of the secret sauce for the skimmer modeling is this user-defined column where you simply enter in the flow rate at each stage that you created when you built your pond. So when you put your pond in, you got your stage storage table, and now with that same stage, you can do the flow rate here. So what happens when your pond's more than 4 feet deep? Well, you've got a couple of different options. You can just extrapolate it. The flow rate curve tends to level off from that 4 foot depth. So if it's just say 4.5, 5 feet, maybe just to go with that same flow rate. If it's much deeper, what we would recommend is go back to our tool that we talked about to begin with. Put in your total pond depth. So the pond depth say was 8 feet here. That's going to the tool is going to break that depth up into 20 different increments, and then it's going to give you the flow rate at each increment over here. So if this is our 6-inch skimmer with a 6-inch orifice, at a 4 foot depth, that flow rate is about 0.78 CFS, and at an 8 foot depth, it's about 0.86. So not a huge increase, just point less than 0.1 CFS increase. But when you're trying to model your pre-post and get it just exactly right, this is the most accurate way to do that. And then you can just enter these flow rates into the user-defined column in HydroFlow. So hopefully that makes sense. When you do that, your schematic is going to show you're not going to see that low flow orifice here that you normally would. In this case, we've got our orifice here, rectangular weir, riser section. But when you look at your stage discharge, you do have that water coming out through the skimmer in this section. Then this is your other orifices kick in. So a little quick way to do that. We do have a much more of a deep dive, step by step on this on our website in our training series. So please refer to that if you need to. Now, we're going to wrap up here, talk about filtration-based water quality. So we have developed a filter to go around our skimmer to be used in either dry or wet ponds. So it's a two-stage system. The outer is a polyethylene fabric. It's just a woven geotextile. The inner is a non-woven called Absorbent. It has benefits that will also absorb hydrocarbons. They have some testing to help with metals as well. These skirts hang anywhere from 2 to 3 feet deep, depending on the size of the skimmer, and they're open on the bottom. And so the idea here is that the skimmer is going to draw water through the top layer, and it's going to, these filters are going to clean the water before it gets to the skimmer. And then if it gets here, we're going to let gravity do the work, and that sediment particle is not going to get pulled up. There's not enough turbulent force coming below the skirts here to get that particle drawn up and get discharged. So it's kind of a combination filtration, settling product. Because of that, it doesn't clog up very much. So it's pretty effective. This was our prototype. So we go back to that same pond we looked at earlier. This was probably our 6th or 7th prototype to try to put this concept together. What we learned is that we had to get the filters outside of the skimmer a little further so that there's enough flow coming through the filters that would keep up with the skimmer. We also learned our inner fabric here, it wasn't getting enough flow, even though it was rated for like 125 gallon per minute flow rate per square foot. The skimmer didn't have enough force to pull the water through. So what we decided to do was turn that into 2 layers. We put slits in it and did 6-inch wide panels. We offset the panels 3 inches. So we created kind of a weaving effect for the water to go through this portion of the filter before it got discharged to the skimmer. This material, I'll describe it as sticky. It tends to grab sediment particles and stuff going through it. And so it's shown to be very effective in trapping the sediment and other pollutants there. One interesting thing we found while we're doing our prototypes was that, again, that material tends to grab everything. So it would also grab plant seeds. And so we'd start getting some vegetation growing around the skimmer. It's not growing in the skimmer itself, but in that filter. And so first we were a little concerned about that, but then we realized, hey, maybe there's potential for some nutrient removal down the road. We haven't tested that yet, but that's something we're looking at down the road. And so after 2 years of monitoring this, we had a time-lapse camera set up out here to keep an eye on it. It was performing very well. You can even see in this photo on the left, the turbidity outside the filter versus inside the filter. There's a noticeable difference there. And then this pipe is the actual outflow from the pond. So pretty clean water coming out of that basin. So we decided to have it tested, and we tested that, had a third party, had TRI do the testing, and we got over 90% TSS removal with the combination skimmer filtration system. A couple of things about the testing is important to understand. So number one is ASTM now has standards for stormwater products. So ASTM C1746 is a standard test method for sediment retention devices. So we followed that protocol. The other thing we did is we simulated the tank to be a dry pond, but we took out a lot of things that normally have in a pond, like a forebay and travel distance. You'll see here on the right side of this photo, this is the sediment-laden water coming into the tank. So it comes in here and goes directly. This is about 1.5 to 2 feet between the inflow and the first filter. And so we did this to be as conservative as possible. And, whatever the results were, they are. So, in doing this, we ran two different skimmers, two different flow rates. One got 92%, one got 96%. So the lab was willing to certify 90+% TSS removal as we scale these. So we've now got our commercial version. We've got it in this pond. This is our same pond we've looked at before. You see the amount of trash in here. One thing about this pond, it's about a 40 to 50 acre commercial watershed that has almost no other stormwater management. So it gets an enormous amount of trash and debris in it. And so we feel like this is a great test site for us. And again, that's it, once it's drained down, sitting on the bottom. This is a little short video here. So we've had beavers invade this pond. And fortunately, the beavers have not figured out how to clog up the skimmer. We had to do a little maintenance, just get a little trash out of it because there's so much trash because of the beavers. But it's still out there. The beavers, unfortunately, the beavers did start gnawing on our skirt, and so they've done some damage to it before. We're gonna have to replace it a little before we intended to. But it's not from the stormwater. It's just because the beavers decided while they're out there, they wanted to play with it, I guess, or whatever they did. So, but you can see in this video, pond's doing what it's supposed to do. Skimmer's draining the pond down slowly. The skimmer's still sized to drain this pond or drain that water quality volume in a minimum or no less than 24 hours. So that's what the skimmer is sized on. So why would we do this? Let's talk about some benefits to filtration versus sediment. So first off, your peak rate of discharge can be based on your filter treatment flow rate, whatever the filter can handle, up to whatever that first quantity storm event is. So what I'm saying is most of the time, from a detention standpoint, the 2-year storm is probably the most common requirement, right? And so if you can size your filter to treat up to that first quantity event, 2-year storm rate, then you can let the water out that fast. And by doing that, you're going to greatly reduce your pond size. Typically, you're going to see at least 15%. In some cases, I've seen as much as 30 or 40% reduction in pond size because of this. The other benefit here is you're going to treat 100% of the runoff from storms up to whatever that filter is handling. Now, what happens when using the first flush method when you get maybe a 1/4 inch of rain over 5 or 6 hours? Well, you get very little ponding. And if the first flush method is all based on ponding to allow time for settlement, and you get no ponding, you get no settlement, therefore you get almost no treatment. Well, with a filter, those trickles have to go through the filter to get discharged. So you're treating those as well. And if you're able to size the filter to treat the larger storm events, now you're treating them. So you may treat much more of the annual rainfall. And the other thing here is your filtration media can be customized to target specific pollutants of concern. Like I mentioned, we've already built into our standard some media that will take out hydrocarbons. So we're kind of, hey, even if that's not a requirement in your specific area, there's an added benefit that you're going to see that help and just enhance that water quality that much more. Some other benefits to doing this is if you do it in a pond, your pond has a very large containment volume, and you're going to reduce your maintenance frequency, and you're going to be able to treat larger drainage areas. So there are other filter products out there. They're typically in some sort of a vault. Typically, they are constrained by the volume of the vault. There's only so much sediment that a vault can handle because those vaults can get very expensive, especially if you start putting in very large vaults. However, with a pond, you got it's much more practical to build in larger containment volume. One of the big ones here, this is where we're seeing a lot of traction, is there's excellent potential to retrofit older basins. that did not include water quality benefits if you can maintain that peak flow rate to do so. So if you looked at an older basin and you tried to go back and incorporate a first flush method, and you put in a smaller orifice that's going to release that first flush over 24 hours or more, what you're going to find is you're going to need another 15 to 30% volume in your basin to do that. And most basins just don't have extra volume built in. But if you can maintain that, if you can get a filter that can treat as fast as that 2-year storm, now you can maintain your peak flow rates and you can add the water quality. You don't have to make adjustments to your basin. And then finally, your filters and ponds can be relatively easy to access and maintain. There are other systems that are involved, so you have confined space requirements, that kind of thing. Be more difficult to do the maintenance within a pond. Either a dry pond, let it dry out, and get out to it, or a wet pond, just pull the rope over and you can get to it. Pull it to the bank. So if we take it a step further and we say, okay, what are the benefits to using a skimmer with filtration? So now we've got our skimmer here and we've got a filter around it, like our model is. So now you've got a flow control product. So the skimmer can be sized to control the peak rate for the lower storm events. So your skimmer is a flow control device, right? So now you've got that flow control. The skimmer is going to increase the filter efficiency. We could go in and we could put a filter in a pond and we could put it down here in the bottom, right? But what's going to happen? That thing's going to cover up with sediment very quickly, need a lot more maintenance. By attaching the filter to the skimmer, we're now treating this water that's higher in the water column. The water's not as dirty, so the filter's not having to work as hard. It's going to last longer, and it's going to, treat that water treat the area where the water's cleaner. And again, pretty easy to access. So again, if it's a dry pond, just let it drain down. If it's wet pond, just pull it to the side. There are some challenges to using skimmers and filters. It's not a perfect product. Number one is they're going to be prone to clog over time and will require maintenance and periodic cleaning or changing. In our products, I'll say we have not seen an issue with clogging. What we have seen is that there is some UV degradation to the outer polyethylene layer. And so we currently recommend a 2-year time frame to replace the filter material. Number two is you've got to have a skimmer that's durable and lasts more than a few years to be suitable for permanent use. So our product's an HDPE product. We've always intended it to be used for permanent use. Now some other manufacturers are coming out with what they're calling their permanent skimmers. So this is starting to gain some traction and be something that's more widely accepted. I don't put it in here, but if I know we have people from the northern part of the country, and so if you get frozen conditions, you may need to put in a alternative outlet, so probably a perforated riser with a valve on it if your pond is frozen and you need to drain it. The skimmers, if you've got a half a foot or a foot of ice, are going to be challenging to use during that time. However, if you've got that much ice, you probably don't have a lot of drainage either. Everything's probably frozen everywhere. So, and then lastly here, there are no established standards for basis of design and permitting based upon the combination of a pond and filtration. So what we see is that most MS4s are looking at this as an MTD, mechanical treatment device, or a proprietary product. Georgia, I know we've got some folks from Georgia on here today. Georgia has pretty widely accepted the skimmer filter for use. We're actually working with Forsyth County in Georgia on a trial project to retrofit a basin. So part of their MS4 requirements, I'm sure we have some other MS4 people on here, but their MS4 requirements are that they look at MS4 owned properties, i.e. schools, police stations, fire stations, county properties. And if those properties have detention ponds that were put in before water quality requirements, they are a part of the MS4 requirements is they try to find those that can be retrofitted and provide that water quality. So far, they've had very little success in doing that because all the ponds require more volume to do that. But with our filter system, we're going to go in and retrofit a pond and maintain that 2-year flow rate or whatever that low flow, lowest quantity event is. So the peak flows don't change. We just simply add water quality by adding the filter. I'll also mention we are in process of going through NJCAT right now. We're just about established our testing protocol. We expect to do our testing the first in May. Hopefully it'll get completed in May. And so hopefully in the next 3, maybe 6 months at the most, we should have NJCAD approval. So for your engineers out there, MS4s that, are looking for that extra level in addition to the third-party ASTM test, we're going to have NJCAD approval here soon. So we'll be getting that out to you as soon as we have it. So we did an example. I looked at a 5-acre site and said, okay, what's the difference between using first flush method for that release for the water quality event versus filtration? For the first flush method, the flow rate going out, in my hypothetical example, I went from a wooded site to a commercial site. So the allowable release rate to drain that first flush over 24 hours was about 0.25 CFS. So the required storage for that water quality event was 0.245 acre feet. Using the filtration method, we're able to jack the release rate up to 0.7 CFS, and so nearly triple that. And what happened is our storage came down to 0.174 acre feet. So about a 30% reduction in pond volume just by using the filtration method versus the first flush method. And again, our filtration method has been tested to get 90% TSS removal. So last poll here. So now that you are aware of the benefits, would you consider a skimmer for permanent use? So this is for all of those that had said no before. Love to know if we've changed your mind. I always have at least one no, and so I've got one today. We got about 50% have answered. I'll do that. So we had one person say no. I respect that. It's really there. Majority say maybe for the right project, or yes, is a good idea. Fully agree. It's not a use it everywhere. It's just going to be a tool in your toolbox. So for the right project, right situation, we think it's a really good idea. So, all right. So we'll wrap up here, talk a little bit about us. I try hard just to be technical, but we'll give 5 minutes about Rymar. So this is our website, rymarwaterworks.com. We work really hard to keep this up to date, always work to improve it. The example I went over earlier about our new size and calculator tool, a perfect example of how we are constantly working to update that. I mentioned briefly, but we have a resources and training page. And so this webinar will be on this page later this afternoon or tomorrow. We also have a training series where we go into the webinar today and break it down into smaller bite-sized segments. These are 5 to 15 minutes. There may also be some things in there that we didn't cover today, like SEDCAD. So I know we have several people from South Carolina on here today. If you're in an area of South Carolina that uses SEDCAD and you're wondering how to model a Marlee float in SEDCAD, we'll take you step by step through that. So please check that out. Hopefully you find that useful. We also have one single download. We call it our Engineer Spec Pack. I will mention that if you downloaded it in the previously, prior to the last week, please go check it out again. I found out we had some corrupt files in there. I'm not sure how that happened, but some of the sediment basin details weren't opening properly. So we've updated that and corrected that. So when you download this, you're going to get a zip file. One folder is going to be our skimmer details, the design tool, test data, supporting information, maintenance recommendations, anything that a MS4 could ask you for on our skimmer should be in that folder. Another folder is going to be the sediment basin details we talked about. Again, there's 4 basin details. There's wet pond and dry pond with both riser and both just temporary pipe through the dam. And then finally, you're going to have our water quality basin details, design guidance. We have a kind of a step-by-step walk you through our recommendations, test data, and supporting information. So got that. And so, why would you choose the Marlee float? So, I do want to kind of toot our own horn here for a second. Number one, material. HDPE is going to be much more durable, UV resistant than PVC. I will mention, I see a couple of questions. We're about to wrap up, and I'll answer those here at the end. So, number 2, flow rates. Ours are extremely easy to adjust. I got a little video coming up to show you how easy it is. We try to make it super simple for contractors to get it right. Maintenance, because of our debris guard, we're less prone to clog. Other typical skimmers are more directly on the surface. They do clog more often. You see them straw that site, they're there. Third-party testing, we were probably the first skimmer to have all of um, our skimmers tested per ASTM requirements. Some of our other competitors have, some have not. Approvals, we're approved by DOTs and accepted by all state agencies. I don't know of any agency that will not affect the skimmer or not accept the skimmer. We're working on the filter. That's a little different topic, but as far as the skimmer goes, some other competitors, some of them have the approval, some may not, but we are accepted by all. I think there's one DOT, maybe Nebraska, that just put in a QPL. We're working on getting it. But if you are from a state or DOT that we're not approved, you've got a QPL, please let us know. We'll be happy to go through the process to do that. We've got all the material. And then post-construction use. We've got case studies. We've had skimmers used for post-construction now for 13, 14 years. We've got a 20 plus year product life. I really think it's probably closer to a 50-year product life. Others, not so much. You don't want to use Schedule 40 PVC. Schedule 80 might be okay, might not. I'm not sure on the specifics for Schedule 80 versus Schedule 40, but I know HDPE is a much more durable product and much more UV resistant. So this is a little quick video here to show you our orifice grate. So number one, these little clips, sorry, sped up a little bit. These little clips make it tool free to do, but that's our orifice plate. So you simply take it out, pop it in. There's a little metal nub right there that makes sure it's centered. And so the orifice, the hole always shows up centered. And then again, you just close it. Again, tool free. So these little clips, you don't have to worry about dropping a screw in the mud or do anything. If you want to go check it out, if you need to inspect it, make sure the right orifice is in there. Finally, here we have 6 different versions of our skimmer. So we have our 2-inch, 3-inch, 4-inch, 6-inch, our standard 8-inch, and our 8-inch with 8-inch pipe. We call this our 8-inch max. We have flow rates, our 2-inch with a 1/2-inch orifice, 250 cubic feet per day, 0.003 CFS. That is a trickle. There are some mud puddles in North Carolina that we see skimmers on, so you may use that there. Point out our standard 8-inch uses a 6-inch pipe to connect to the outlet. All of our other skimmers use whatever pipe the skimmer is. Our standard 8-inch has a max flow rate of about 1.5 CFS. That's still about a 1/2 a CFS higher than most competitors' 8-inch. Our 8-inch with 8-inch pipe has a flow rate of almost 2 CFS. So if you're, we're doing a lot of solar jobs. So if you're an engineer working on solar projects and you got these massive sites and massive basins, we've seen some basins with like 5 8-inch skimmers. You may be able to reduce it down to 2 or 3 of our 8-inch with 8-inch pipe to do that. So just be aware our 8-inch flows faster than just about any other skimmer out there currently. So, and that pretty much wraps us up. If you need a PDH certificate, please shoot us an email at info@rymarwaterworks.com. We'll get that right out to you. I do have a couple of questions. Let me look back at the chat here. All right, let's see. I'm looking into grants for stormwater infrastructure upgrades, repairs, have the skimmer help secure funding for projects and give good case studies for all. So Jesse, please shoot me an email. I'm not sure where you're located, but we are working, like I said, we're working already with several MS4s in Georgia. And we're also, we're also looking for test sites. So North Carolina has a pretty rigorous system for proprietary products to go through that requires being on sites and tested. And so we'd love to find somebody that we could partner with to do some of that. And then I got another question: could skimmers be used in wastewater applications for removing scum from the top of the water? Maybe we can look at that and be glad to talk to you about that. We've used skimmers. We've adjusted our skimmers some for wastewater where they wanted to withdraw from just below the scum and kind of dewater the tanks from that, but not capture the scum. I'm not a wastewater guy, but we can be happy to talk to you in more detail. We can modify our products pretty easily. And just, yeah, Winchester, Kentucky. Yeah, we'd be happy to shoot me an email. We'll be happy to do a follow-up offline here and kind of talk about that. in more detail. I got it. I'll copy your email and I will be in touch. So anyway, hope that was if anybody else has any other questions, feel free to unmute and ask. We're right at our time. Want to be very respectful, and or you can put it in the chat. So appreciate everybody joining us today.